Okay, let me share my screen first. Entire screen. Okay, hope my screen is visible by now. Is it visible? Yeah, I guess my screen is visible. Okay, mostly what I will do today is that I'll demonstrate directly. I hope all of you present here or will be actually consulting these lectures later will know something about Python, because I saw there are some basic lectures on Python in this schedule of lecture talks. So I'm not going to tell very basic things about Python, but what I can emphasize is that Python is a very versatile language. It has fantastic data structure. I mean, the most important thing is that it can handle huge amount of data in very many different kinds of forms, so that it is useful in any kind of work, be it in social science, be it in basic natural science, in like astrophysics, general physics, or in industry, or in any kind of work. So we get data in very many different kinds of forms, in arrays, in one-dimensional arrays, in two-dimensional arrays. So with Python, we'll show you how you can handle data, how you can manipulate data, and how you can cook the data to get the model out of it, and to proceed. Okay, so let me go to the demonstration part first. I will mostly prefer Anaconda Jupyter notebook. If you do not know this, I'll tell you that this is the most preferred platform where the Pythonistas, I mean, mostly who do machine learning, data, deep learning, or any kind of AI work, or data science people, or anyone who uses data, they prefer this Jupyter notebook. We have one such notebook is open. You can directly uh, start writing on this shell and get the answer here, and you can prepare a very nice sheet of things that will be fine. Okay, you can present later with this sheet in, as a instead of PPT, or you can make it a book later. Okay, but anyway, I don't know how you were introduced to Python, but if you go to Python org, Python official site, if you download directly therefrom, you will see there is a like this idle idle is integrated development and learning environment. That means basically it's a platform, or it's a command line where you can write all the Python commands. Python is a full-fledged language. It has a fantastic data structure, and more importantly, it has all the kinds of necessary modules. You can call it libraries, fantastic community helps, so that later if you learn a little bit of Python language and then use those models, then it will be of great help of any person who is doing using Python, who is writing full-fledged programming language, who is just using some app of Python or anything. I think it is better to learn a very little bit of Python, I mean the basic syntax, and then use the data structures. I'll tell you that if you open this Python platform, that means the idle. So I mean, it is a very basic, very common from Python org, Python official site. And you start just if you write BIR and just blank, you'll see lots of names, and all the names are very specially written with double underscore being at the beginning and doubles underscore at the end. So suppose these are all Python's I mean the internal ways of writing things. but we are not going into detail of how those are written, and etc., etc. But suppose if you check what is this inside, for example, in this underscore underscore built-ins underscore underscore. So you write dir, that means directory, and this underscore underscore built-ins underscore underscore. You will see lots of names. You see lots of names. Again, all kinds of names, and then there are some names which are written with double underscore in the front and back, and then there are some names starting to from A to Z. These names you can you always use when you write codes, or when you manipulate a code or handle some app or something like that. This apps means absolute value of something. These kinds of things. Bin means you can convert some number into binary, decimal number to binary, and so on. Len means len of some data structure or something like that. All these things are basic names are here. You call it you call this space is namespace, and the names are already here. So you can use these names. For example, if you want to print, that means you have to give print command. That means the print name is there. All these things are here. So this is the built-in library. So this is the built-in library. You don't have to refer this library, refer any name to use from this library. For example, if you write ABS and then minus of 4.5, for example, so you will get 4.5. So that means you are using this name from this built-ins library, or we call it module. Okay. So please ask any question or any if you have any doubt, you will always just ask me. I'll prefer that way. Okay. So this is the built-in module. But apart from that, there are lots of modules inside this basic Python. For example, you have a module called math. You may have already you may already know this. Import maths. So you just import this library, because this library was not here in this namespace. That means where you are working. So you are importing this math. Import means this color. See the color change. Import means this is something, some Python keyword. This is very special keyword. With this keyword, you are actually import this math module here. And again, you use dir. Inside that, you write math. That means basically dir is a function, like ABS is a function, Python function. Function means it's a block of code with which you can work, do anything. Okay, so here you have dir math. That means what you are asking, what is there inside this math module. That means you are checking the math module directory. So you have all those names again. Ignore these names, special names, but you start from here to here. People who know a little bit of mathematics, you will know that this sin sine is a sine function. Then it's a sine hyperbolic function. Then it's a square root function, tan function, pi, the value of pi, power of something. All these functions you can use from math module. For example, if you want to use this square root, SQRT, that means you have to refer this math module, because this is inside this math module and not in the built-in module. So now this time you have to refer math.sqrt, and then you write, say, for example, 4. That means square root of 4 is 2. Okay, like this. So you want to use this power, POW. You can write 2 star 3 is a 2 to the power 3, but you can also write math math.pow 2, 3, and you can use this power function and so on. You can use this sine function, you can use this log base 2 function, etc., etc. All these things are there, but how do you know what are those about? For example, this square root. Then you write another function, help. Help, inside this, you write math.sqrt. It will give you, it will write this about this module and this function. it's written help on built-in function square root in module math, and this is the function. You have to give the name, and for the time being, you ignore this. It writes return the square root of x. That's it. If you write, say, help and then math dot sign, it will write this. In Python, it is the most advantage is that every information is here. If you use any function, if you use any module, about the kind of manual is always online. So you can, once you download or install Python in your computer, whether you work in Windows or you work in Linux or in Apple system, I mean the Mac system, or in Android in the phone, your mobile phone, it doesn't matter. Once you install Python in your machine, you have all the manuals are here. So remember two things. One is dir, one is dir. That means it will show all the names. That means what is there in the directory. It's a function. It's a built-in function. It is there in the built-ins. It is there in the built-ins library, built-ins module. Okay, and here about the other names, you have, I mean, knowing about the names, what they do actually. That means the manual. You have to type the function help. So remember two names. One is dir and one is help. That means when that means it is advantageous to you whenever you use any Python module, whether that is in the basic Python or you import from somewhere else. I mean that means external modules or anything. You always use these things at the beginning. That means you check what is there in the module. I mean what one particular name, what is there behind a particular name. That means the manual or anything. Okay, so that is how you use Python in your machine. So you will always feel confident. You don't have to ask anyone. Even if you don't, even there are lots of books, lots of free books. Even I have written a couple of books, but that doesn't matter. I mean, you may not require any book at all. You go to your machine, you discover everything step by step. Okay, once you know how to check the things here, all the things, all the help is here, and then you go to internet. You'll see that there are lots of community sites, lots of documentations itself in Python sites, and so on. So you are with this message in mind, you start. Okay, I hope you know the basic rules, some basic syntaxes in Python. For example, how to write a very basic code, like how to use a loop. That means a loop. With the loop, you just iterate something and you sum a series of numbers or something like that. That is a loop. How do you use logic? That means if statement. If this is this, then you do this. If not, then you do this. That means else you do this. This kind of logic, that is in those things are there in every computer language. And important thing is that Python is the simplest language to follow because it has the simplest syntax, clean syntax, and the minimal syntax, so that you will learn them quickly. Once you follow some basic logic, if you follow the some programs or write some little bit small codes like sum of some numbers, find some prime number, or make a square root of these things, that thing, small things. If you write some little codes, little bit of that, you will actually learn a bit of Python. And the next stage is the data structure. I'll just want to emphasize this because let me write here on the board. Let me go to the board. Where is that? Where is that? Okay. Probably I can write here. Probably I can write here. Let's see whether I can write here. This. Okay. Okay. So just a minute. Okay. Okay, now I talk about Python data structure. Oh, what is this happening? I don't know what is this mood board. Is it that? What is this? I want to, achha, okay, let's see. Let's see. I want to create and to open this already open board. Okay. Hold on, please. Okay. Oh, it is showing me something bizarre things. I don't want this. I don't want this. This is a problem with Microsoft. They will show me. Uh, no. Okay. So review. No. Do I do these things? No. I don't want this. Hmm, okay. So I'll come back to that. Okay. So basically, what I want to tell you is that I write here data structures. Okay. This name I want to write. Data structures is the how you present data in Python. This is in basic Pythons. There are some names you will see. You will see inside the data structure. There is some name. One is list, and then tuple, and then tuple, and then string. You have already heard of these names. Okay, string, and then dictionary, and then set. These are the few data structures, and each is designed in a particular way so that you can handle it. For example, I'll show you an example of list. For example, I write, say, x equal to sum with a square bracket, say 2, 3, minus 9, 0, 1, 10. For example, I write these numbers in between two square brackets. So this is a list. You want to see what it is inside this type function, you write what it is. It will show you. That means this is the list class. Forget about what is class. I can tell you later if anybody asks. Okay, so this is the list. List is one type of data structure. And what is this to do? This is an array, some kind of array. That means a sequence of some numbers included between two square brackets. So if you write dir, inside this you write list, you'll see some names. Because I told you that this list name is inside already the underscore built-ins underscore. And again, forget all those names and start from here. Append to sort. You will see under the list name, there are some names which will help to realize the full potential of list. That means there are some names. For example, append. You can see from the name what it can do. Append means it appends some number or some element inside this list. For example, if you want to see what this append does, then you have to write help and then list dot append. Okay, list dot append. See, help on method. It is called method. It's a function. It's a function. I mean, this list append is a function, but since it is a special kind of function which is helping this list to realize this some potential, so that's why it is called method. In Python, we call these special functions as methods. And what this method does inside this append, forget about this self. This is something reserved for something, and this some object. In Python, everything is object. You give something here, and it will append here. And append object to the end of the list. For example, X is a list. If you write X dot append, okay, and then you write say 100, and see the list 100 is appended here. This way you can manipulate things. You can remove some element. You can pop out some element. You can insert. You can reverse the list. You can sort the list. That means you can actually, arrange the numbers in the list in the ascending and descending order, and so on. So here is the small introduction of the list. Similarly, you have tuple. If you write tuple, some people call it tuple, some people call it tuple, and you see in the tuple, all these names, ignore them. Only two names, count and index. That means you can count some members or something, and you can do some about index. You can see what they work. You can also use the help function to see. Okay, like here you did. So here's a list. Then there is a dictionary. Then there is a the set. For example, if you have x equal to say for example 2 6 5 3 2 2 9 1 etc 6 etc. For example, if you write set of x, you see what it is. It will collect the unique numbers. That means 1 2 3 5 6 9, because 2 is repeated here, so it collects 2, and the 6 is repeated, so it collects 6, and so on. So its set is a collection of unique numbers. Like this way, you will get to know the characters and the of all the data structures. When you write full-fledged Python programming code, so you will actually use them cleverly, and you can see some examples when you actually use the some imported codes, or you write for on your own. You'll see that you can use list, tuple, set, dictionary, and of course string. Anything you write inside a string, right? Suppose a equal to something abracadabra or something something something, or if you write anything, so here is a list. Okay, so if you type, you write a, so this is a string. String means something, whatever you write between two quote, two inverted commas. Okay, so there are all these kinds of data structures. These are common. Once you learn basic Python, you get to know about all those data structures. So I have given you some quick introduction of something about Python. The basic syntax I have not talked about. You already have learned, I guess. And then there are the data structures. These data structures are beautiful. They are actually pre-processed. Many of them are pre-processed through lower level language like C and so on. And when you handle data, actually large data, large array of data, you can you can see how this is you are getting the advantage of all those things. But I am not going to discuss them thoroughly here. Rather, I will go to tell you about some imported data structures or some imported modules. One of them is the NumPy. I'm sorry that this board is not working. I cannot know how to quickly start this board. Let's see once again. Otherwise, I could write something here. Okay. Let's see whether. First of all, it is slow. Let's see whether it comes. I wanted to have the whiteboard here. I'm sorry, but it's not working. Okay. Okay. I don't want this. Let's see whether I can. Whether I can get the pin. Then I can write. Just a moment. Huh? See. Here is a pin. Is a pin here. In linking. Select. Let's see what is there. No. Okay. Oh, here I get it. But I get it. Okay. So yeah. So here is the, I can write, here is the data structures. Data structures, what I talked about is list, string, tuple, dictionary, and set. These are the in basic Python. This is in basic Python. Okay. Now I'm talking about some, and in Python, I have already told you that there are built-in module That means underscore underscore built-ins underscore underscore, where from we are using the names of the functions. And then there are other modules in basic Python. Okay. For example, math, you have a module called random, where it creates lots of random numbers. Then there is module called sys, there is module called time, then there is module called calendar, and so on. There are lots of hundreds and thousands of basic modules in basic Python. Now, what I will emphasize in today's talk is that there are some external modules. There are some external modules. There are some external modules. Okay. And one such important external module is called NumPy. NumPy is numerical Python. NumPy is numerical Python. That means all the kinds of data or numerical data you will be handling for your research and other higher level works, you will have to use this NumPy, NUMPY. Then there is another module called SciPy. Remember, there are hundreds and thousands and millions of modules, external modules people have created for our work. Like people in geography, they have created GeoPython, they have created their own module. People in biology, BioPython, people in cosmology, CosmoPython, and there are lots of things, lots of modules, not only these only. And people in physics, in other areas, in economics, and all social sciences, and even in literature and other places, people have created their own modules for their own work. You can always download these modules free of cost, and you can install on your machine and start working. All you have to do is that after you installing, you have to just import the module first, write on your namespace, and then start working. Like you check your directory, you check with the help file of particular function, and so on. Okay, so among the external modules, there are two very important things are there, names are there. NumPy is numerical Python. NumPy is numerical Python, and SciPy is scientific Python. This is mostly useful for people, mathematically oriented people. That means people in physics, people in big call. Sorry, can you please respond whether you can hear me also, because I'm actually connecting through my phone. Can you please?
Yes, sir, we can hear you.
Yes, sir.
Yeah, okay. Because I'm just it's a kind of monologue. I'm just lecturing and I cannot see you, so that I'm often confused. Okay, so yeah, NumPy, SciPy, and then there is another very important module that you always require is matplotlib. That means some of you have used MATLAB. It's actually MATLAB style plotting library, but it is free. Unlike MATLAB, it is free. We can call it mathematical plotting library. And then there is another one, it's called pandas, means panel data, all the kinds of structured data. That means data you are getting like an Excel sheet or in something like two-dimensional, any kind of spreadsheet or any kind of text file or any kind of very many different kinds of files of data, like sound and music and all kinds of things. You can handle them with this pandas module. Actually, these are the four modules which are at the base of all those higher level works, all those production quality work. It's numerical Python. It's numerical Python. Is scientific Python. Scientific Python, and it's a mathematical plotting library, and it is for structured data. structured data. You can actually create an Excel sheet. You can actually read an Excel sheet. You can actually do anything with these things. So these are four names are very important. If you are into Python, if you are planning to learn Python, then you can obviously, you will encounter all those four names, and eventually you will learn all those names. I mean, they are, I mean, kind of infinite resources, but you cannot finish them in your lifetime anyway. But still, when you write codes, when you handle data, when you do any kind of work, analysis or anything, data analysis or anything, you will need all those. I mean, most of them four. And just believe me, all the other fancy, very many fancy softwares, fancy apps that are based on Python are actually based on all those four things. And among them, if you want to select just two, then I will tell NumPy and Matplotlib. NumPy is necessary for numerical Python, means it handles the arrays of numbers, means one-dimensional numbers, two-dimensional numbers, three-dimensional numbers, and Matplotlib for visualization of your data. Okay, so if you do not already have not got introduced with this two external packages, external modules, or sometimes they are called packages. Packages are the superstructures. Packages are collection of modules, and modules are some basically a big library or big Python function where you have everything. You can actually use part of it for your purpose, like importing something name and then using some name by connecting it. Okay, so I'll give you some demo on all those things. Okay, you will see the machine learning, data science, all these names you will hear: tensor, flow, this scikit-learn, then Seaborn, all kinds of packages you will hear if you are into data science and machine learning and things like that. Then you will see all those fancy packages are actually built on all those things. So I'll tell that whoever does anything in Python, I mean, after learning the basic Python, you have to just get into this NumPy. NumPy is a fantastic package. I'll just give you a very quick introduction, and then I will give you direct demo of I mean, the production quality work in one lecture only. Okay, so let's see here. So if you want to use NumPy, that means NumPy is an external package, and I have already installed in this machine. So you have to, like all other modules, you have to import NumPy, and you can give it a local name as np. You see, this import is a special keyword, and as is a special keyword. NumPy is the name, np is the given name. So if you write this, it will take little time, and the NumPy directory, I mean, the NumPy module or the library is here. So if you write dirnp, you'll see the directory of NumPy is here. It's a huge library. You see lots of names. Some of the names are even another library. That means that they are again modules, and then inside the modules there may be sub modules. So you can explore all of them, and some of them are mathematical functions and all kinds of things. I'll give some examples. Inside this NumPy, there is a function called array. So if you write, say for example, say x equal to np dot array. Yes.
So actually, I'm doing parallelly with you. So you said that it's already installed in your this thing, right?
It is installed in my machine. It is installed in my machine.
Suppose if it's not installed in my thing, then
then you have to install it. Yeah, I'll tell you later how to install it. There's a process, but if you have your own, I mean, I'll tell you. This is the basic Python idle I am using. This is useful for students or very quick use. But I'll tell you, if you plan to work Python, when you use Python all the time, and I mean, use data and things like that, do a heavy kind of work, then I will tell you to install this thing, this stuff. This called this Jupyter. That means basically basically you have to, best thing is that you actually, this is the Anaconda navigator. Okay, you'll see this navigator. Okay, here
So
here I
I
actually actually started this Anaconda navigator, and these are all the options. One is the Jupyter notebook, you'll see, and there are other options, Spider, etc., etc., Jupyter Lab, etc., all kinds of things are there. Okay, so
actually I was getting an error
yeah,
like no module
sorry.
name NumPy. So I was getting when I did the same thing import
Yes, yes,
NumPy and LT,
because
I
NumPy
got.
is not, because NumPy is
Mm.
not installed there. If you use Anaconda, then it is already there. Okay, I'll tell you that in Python there are lots of distributions where you get some packages that I talked about: NumPy, SciPy, Matplotlib, Pandas, all these things are pre-installed. You don't have to install them. So one such thing is that Anaconda. Okay, one such thing is the Anaconda thing. If you just go to Google and just directly download Anaconda, then you install. Installation takes little time, and then Anaconda Navigator is ready, and then therefrom you go to Jupyter. And later, if you want to install some other apps in it, some other modules in it, you can also do that. I'll tell you later. Okay. Or if you have my book, I have in my book there are things explained in the appendix and things like that. And inside this, what I'm using actually is this Python shell for quick work, quickly to show you. Here, actually, you have to install all the external packages yourself. Okay, here they are not pre-installed. Okay, but in my machine, I have already done that. I mean, and the installation of any package or any external module is so easy. Actually, what you have to do is that you have to go to actually CMD. That means the black window will come. Okay, the command prompt window will come. Actually, my machine has got slow, very slow. I don't know why. Or I have to restart it anyway. I had to. But anyway, if you go to there, you go to CMD, uh, then the black window will come, and there you go to the directory, Python directory, and you have to just write pip install and the name of the package. That's it. It will take some 2 minutes, 1 to 2 minutes to install. That's it.
So
Once,
do we have to put a exclamation mark before that, before skip?
no, 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 no,
No
no, no,
required.
nothing,
No.
nothing, nothing. This is direct. This is direct.
So actually, we are
Okay.
getting some
Uh,
different commands. Last time, I think yesterday only we did one
I'll show.
installation.
I'll help you. I cannot. I'll help you actually later after the talk maybe, or
Sure,
later
sure.
through WhatsApp. I can help you. No problem. Where you are
Okay.
stuck? If you send me your screenshot where actually you are stuck, I can tell you. Okay. So actually, in short, what I'm telling is that you can use anything. You can use this basic idle and this basic Python idle. You can use this Anaconda. You can use another Python XY. You can use PyCharm, lots of different distributions are there. So you can actually use any of the distributions or basic Python idle this thing. Okay, so that's no problem. So I mean the how to install. I mean in this basic Python stuff, you have to actually install uh, these packages separately. Otherwise, in all other things, you don't have to install the packages separately. Those are already there. Okay.
Okay,
If you go to CMD, actually it should come.
it's okay, sir. You
If
carry
you,
on. I just
it's okay.
wanted to see. I
Okay,
wanted to
okay.
know how do
I'll,
we
I'll,
do.
I'll I'll show you. Once I
Okay,
restart the machine, it will be faster. I'll show you later.
okay.
But I'm fearing that my network will go because I'm
No,
actually
it's okay,
connected
sir.
to
You
the
carry on. I
mobile.
just had a query regarding the installation.
Okay,
So
okay, okay, okay. Suppose you are using this NumPy, right? I hope you can see that. You can, because since it's the last line, I can uh, put it up. Okay. So suppose you are writing 1, 2, 3, 4, 5, and 6, and so on, for example. You see inside that is you can recognize this is a list, but you are putting inside this stuff inside this numpy dot array, np dot array. So it's a new kind of thing. It's called array. So if you write what is this type of X, it will always show you that it will show you this numpy nd array. That means n dimensional array. That means multi-dimensional array actually. Okay, this is actually 1D array, but you can have 2D, 3D, 4D. You will recognize that in physics we call 1D array is a vector. It's a 2D array. That means you have rows and columns. Most of the data will come in 2D arrays. For example, if you write a table, and on the table you have rows and columns. So basically, in terms of computer language, it is 2-axis. 2-axis means 2D array, two-dimensional array. Then similarly, you can stack this 2D array one after another, and you can put up, create a box of data. Then 3D, 4D, 5D, ND you can create. That when the people are doing in a higher level of work, they use 3D, 4D, and all kinds of things. But anyway, we're not going into detail of that thing. The fantastic thing is that, so X is now NumPy array. Okay. So let's see another list. For example, your list is 1, 2, say 2, 3. Let me do it 2. Suppose I want to create another list where each number is the square of the previous numbers. So what I do, I have to write a elaborate program, because I have to take 1 and then square it, and then I have to take 2 and then square it, then take 3, square it, and then they collect the numbers in another list and so on. So you have to write this code in 3, 4 lines, 2, 3 lines at least. If you write obviously y start 2, that means y square 2, it's not, it will show you the error, type error, because it doesn't understand. Y square means what? I mean, you can square a number. You can say a equal to 6. Then you can write a square. That means it's okay. But if you have 3 numbers together, more than one number together, that means it is a list, and you cannot do that. But here you see, let's see x. Okay, if I write x starts at 2, that means it will. That means I am trying to tell computer that okay, x square means, square the array. That means it is actually squaring all the elements. That means 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and so on. And also it is writing data type. That means integer 32. That means it is actually taking the data as each data as in a processor is a 32-bit. These things I can actually increase the memory size, actually decrease the memory size. That's all matter of expertise later. You don't need at the moment, but when you deal the real data, you can actually need that. You may actually need that. Okay, so you see the magic here. This thing is already pre-processed, done. That means that's why you will be using Python. That means your labor is saved. You will be doing lots of other important works. You don't waste your time to write a code so that it will write the square of each numbers and then collect the numbers and make another list and so on. It's already done here. How it is useful, right? For example, I create a list of numbers. I can use another function from NumPy. So it's called linspace. Okay, it's called linspace. And linspace means linear space. It's there in the NumPy. If you look at this directory, you'll discover there. So here I have to start, let me start from a number 2 and go to number 20, and I create, say, 100 numbers, for example. You see, I have created 100 numbers. So let me create a small array. np dot linspace, and then say 1 to 10. Let me say 0 to 10, and say 11 numbers, for example. You see, 11 numbers is 10 gaps. That means 10 by 10. That means 1. Okay, I can create from say 0 to 5 numbers. So I can create this. So that means it is the start, it is the end, and this is the number of numbers. How many numbers want to create? I want to create 11 numbers. That means 0 0.51, 1.5, etc., etc., etc. It has already created equispaced numbers, linearly spaced numbers. So I can create any number. So now I can write np dot square root of x. What does it mean? I'm using the square root function that I use from math module. I'm using the square root function from NumPy. Okay, and here it can actually do the square root of all the numbers separately. You see the magic? Here it is. That means square root of 0 is 0, square root of 0.5 is this, square root of 1 is this, and so on. So it has actually created another array. So that's the magic actually. Okay. So if you write import matplotlib.pyplot as plt, you see, I am actually calling the matplotlib module, and inside that there is a sub-module. I mean, this is a package. Matplotlib is a package, and inside that there is a module called pyplot. It is dedicated for XY plot. I mean, the usual graph plot we do on 2D. Okay, you can do 3D plot and so on. We can do contour plot and so on. So, suppose I am actually calling this pyplot module from matplotlib package, and I rename it as PLT for my easy reference. Okay. Now, if I write use these two things, x and np dot square root. Let me call it, say, y, for example, here. I can give any name anytime. So x is this, y is this. Okay. What is it? Y array is the square root of x array. Now we can write plt dot plot. That means I'm using this plot function from this plt module, and I write just x comma y. That's it. So it will actually write plt dot show here in this case. So it will actually show the graph. Okay. So as simple as anything. Okay. So you can use, suppose how do you know what is there inside the plot? I mean, how do you use the plot function? You see, you write help, and then you write plt dot plot, and you see this manual. It's a huge manual in this time at this time. So plot, I will later tell you what this means. Star args means joto khushi arguments, means as many as you want, and then there are lots of other keyword arguments are there. You may not have to know all those details. You will eventually know everything if you actually learn Python thoroughly or use things regularly. Okay, so you see the lots of examples here, lots of things, lots of I mean the demonstrations, lots of lists. You'll see the markers. You can use markers. You can see the styles and these things, that thing, color, and so on. For example, I wrote plt dot plot, and then I can write x comma y, and then I can use dash and then O. That means it will write a bullet plt dot show, and you see this is these bullet marks, and this I can manipulate each of the element of this graph. I can actually write axis. I can actually increase the tick size. I can give colors. I can write legends. I can create all kinds of things. If you go to the matplotlib, I mean the manual or the matplotlib chapter in my book, you can actually get to know everything. You can actually put color. Actually, you can put color. Say color equal to, for example, color equal to red, etc., etc. We can actually all kinds of things you can do. This is a little demonstration because in one lecture you cannot do everything. We will be quickly running out of time, so I'll actually go to the actual data demonstration with actual data later, a little bit later. Okay, so another thing I wanted to show you is that x is, suppose this. Let me create another x. X equal to np dot say, for example, this time I will create with another function, a range. A range will create an array. Suppose I want to create from 2 to say 10, and I wanted to create data. I want to create data with step size, say for example 0.05. Okay, so here is the array. Oh, this is, I don't know how many numbers are there. 160 numbers are there. Okay, let me create another small array. np dot linspace. Linspace is this is, say for example 2 to 10, and say for example Say I want to create 16 data, for example. I'm doing it purposefully. So I have 16 data. Okay. The data are actually looking, I mean, this way. So let me also write another function before it. Np dot round. What is round does? Round means the name will be from the name. It will be clear to you. This round means is that it does round off. But since every function in NumPy is a it's a basically it's called vectorized function. That means it will actually apply on all the elements. Just a moment, huh? Just a moment. I'm taking just 2 minutes break because I have someone in the house. I just have to talk and come back. Okay, let's just yes, I'm back. Okay, so now if I put np dot round in front of it, that means it will actually round up each of the numbers just to see it properly. And if I write 2, that means I actually want 2 decimal points. So if you write this, so x is this. You see, x is this. 2, 2.53, 3.0, C, and so on. Okay, so you have actually 60 numbers. Okay, and it shows the approximate way that way. Now, actually, I want to fold these numbers. I want to create. I want to. X is a now numpy array. Right? If you write type what is x, x is basically a numpy array, and numpy array have lots of characteristics. One thing is that you can actually do manipulation over the data. You can actually fold data. It's a one-dimensional. You see, one square is there, one square is there. It's already it's a I write x dot
So your voice is breaking.
write is breaking. Okay, I'll come in again. Let me uh, leave the call and then I
স্যার
go in.
আপনার আওয়াজটা কেটে কেটে আসছে
আমি ঢুকছি, হ্যাঁ
হ্যাঁ হ্যাঁ হ্যাঁ ঠিক
আমি ঠিক আবার ঢুকছি, ঠিক হবে। Is that okay again? Now you can hear the
ইয়েস
yeah.
স্যার
Okay,
Yes.
okay. Enter screen, share. Okay, so I hope now again it is okay. Okay, so now I reshape this array into say 16 numbers. So I say it is say 4, 4. That means I want to make it a 4 by 4 array. You see, I have actually created a matrix. You see that I have created a matrix. Okay, so it's a 2 square brackets here and 2 square brackets here. Okay, now you see, if you now I rename it. For example, I rename it say y. If I now y give y square, that means it is the square of all the elements. Okay. If you now write np dot sum of x, it actually sum all the elements of this, But if we write np dot sum x and then axis equal to 0, just hold on, I'll show you. Okay, if I write x axis equal to x, oh, it's not x. I'm actually trying to do it on y. Actually, I'm trying to do it on y because y is important. If I write y of this, because y is 2D data, so you see 96. But if I write np dot sum and then y, then axis equal to 0, you see what happens. That means axis 0 means actually up down. That means sum of these plus these plus these plus these. You see the total is not this. Axis 0 means actually, sorry, y. Axis 0 means y. Oh, I'm sorry, y is here. Let me show you y. Y. Yeah, y is here. So that means sum of these plus these plus these plus this is 20.8. Sum of these plus these plus these plus this is 22.93. That means it is actually summing up and down. That means it's actually, you are doing actually the column sum. This is the column. This is the column, sum of this column, sum of this column, sum of this column. So that's what is the magic is. If you write, say, np dot sum and then y and then axis equal to 1, you'll see this is the sum of these elements is 11.2. That means you are going along a row, and you are going along a row and sum it and write it this. Sum of this row is this. Sum of this row is this. So all these facilities are there. How do you know this? What is this axis about? You don't have to remember everything. You just go and take the help, online help. np.sum. You see what is written there. The only thing is that you have to read. You have to learn to read the manual. That's it. And the manual is written by basically by science research scholars and students in USA and everywhere, Canada and everywhere, so that it's actually readable, it's actually useful for us. Unlike the computer scientists write in a way, in a jargon that we don't often understand. But here, these things are written by scholars and PhD scholars and all the teachers and everything. Okay, so see, sum of A means some object, sum of some array, 1D, 2D, anything. And then axis, usually it is given none. The type of data, etc., all these things are there. You see this axis. What does it axis tells? See here, none or int or tuple of units, etc. You will see these later examples. Okay, you will see later examples. You'll see later examples here. Okay, so you can understand from the examples, even if you cannot understand from the writings sometime. You can actually give multiple axes and so on. That's what it is talking about in a general sense. But axis or axis along which the sum is prepared from. This you can understand, I think, clearly. Okay, so in every function, you can see through help, you can see what are there in the directory, and you can use all the names this way, and you can quickly learn to handle and manipulate the data. There are lots of statistics package, etc. Lots of things are there. Still, I want to show you another package, which is called pandas. Import pandas as pb. Okay, this I told you that this deals with the structured data. Okay, so what is there in panda? Okay, once again, go and see what is panda. Pandas means paneled data. Okay, so you see lots of names are here. Okay, read Excel, that means you want to read the Excel file, read CSV, comma separated value files, etc. Okay, all the text file we write, whether we give comma or not, they are called CSV files. We create all those things all the time. Okay, for our own purpose. So suppose I want to use this PDF, and there is a function called data frame. Do you see it here? Data frame D somewhere here. Okay, let's not waste time. So PD dot, let's say x equal to, for example, let me create x equal to say np dot array, or say simple 1 2 3 3, then 4 5 6, and so on. Suppose this. Suppose you want to create PD dot data frame. You remember this is this data frame, capital D, capital F, like NumPy array. It is based on NumPy array. It is another higher level structure of data, which actually can give you in the column and row names. We can create from data a beautiful table. For example, I'm giving you just showing you just a very simple idea. So X is a 2D list, or maybe you can write as a NumPy array or whatever. It's a two-dimensional data because we have two square brackets. So if you write this, you see the datas are 1 2 3 and 4 5 6. See? And these are the index, column index. Automatically, this is 0 column, 1 column, 2 column, and this is the row index, 0 index, 1 index. How does data frame behave? What it is there? If you want to see, then you want to have write help and then PD dot data, then frame. You'll see the oh, it's a huge, actually. It's a very big. Actually, data frame manual is very big. 20,035 lines. It is writing actually these things, but you can read the first few lines and can understand. Okay, for example, I write PD dot data frame and then write X, and then index equal to say I write say 10 comma 20, for example. Let's see what happens. To see 10 comma 20 is the index. With through this index name, it's actually called keyword argument. With this keyword argument, I am giving the name 10 and name 20. Okay. If I write, say, for example, column names, I give columns, say 100, 200, say 300. Okay. So no problem. So it is, see, if the index, automatic index numbers 0, 1, 2, 3, 1, 2, these are changed by 100, 200, 300 as I have given. Remember, in Python, as you already know, everything, all the counting automatically starts from 0. If you tell or not. If you tell something, then it's okay. But if you don't tell, by default, it starts from 0. So it's a data frame, basically. It's a data frame. You can play with data frame. You can play with NumPy array. You can play with any function, etc., etc. One important thing is that these this data frame or NumPy array or any NumPy function, they are actually called vectorized. What is called? It's called vectorized. I can tell you that these basically these NumPy arrays and functions are actually this mechanism called vectorized. Vectorized means all the mathematical operations or any kind of operation, algebraic or any kind of operation, these operations will be on each element of the array. For example, that's what we showed, that if I write x equal to np dot array y, and then 1 2 1 2 3 whatever, then if I write square, then it will be square of these, square of these, square of this. If we want to take sign of this x, if I want to np dot sign of this x, it will be a sine function of 1 radian, 2 radian, 3 radian, and so on. Okay, so this way we can actually manipulate data very easily. We can create data easily. We can actually shape data. We can reshape data. We can stack data one after another. We can deal with different arrays of data and so on. And then finally, in pandas, quickly, I told that we can deal with actually the structured data which has actually the names along the rows and columns and so on. Okay, this is a very general introduction in a very quick way. I think you have at least part of it, it can be easily can be useful for it, if not all. Once you go on using Python for your work, whatever kind of work, you will actually learn each day. I mean, it's very easy and very not only easy, it's very magical. It's very magical. Once you start working with Python, it's so life will be so easy that you will be actually addicted to it. Actually, okay. So let me go to the this basically. Let me go to the demonstration purpose, but I mean the actual data demonstration. Okay. So by now, I mean, if anyone wants to ask any question, please ask me so that I can know that where can be possible problem. Okay. Do you have any question, please? If not, then I'll demonstrate the actual real data. I think, I guess there is no question. Okay. Anyway, I'm not sure whether what I'm talking about can go through you, because I mean, many of you may be using Python for the first time. So, but anyway, I'm trying to tell you giving you the, trying to give you the very overview of the what is actually done in data science, in machine learning, and all kinds of things, or any kind of model building that we'll be doing. Okay. For example, I mean, the rest of the topic will be named as how to, I mean, handle data in Python, or actually the name I gave, the understanding data with Python. That's my purpose actually. Okay. So with the basic thing that I have told, I mean, with this, keeping those things in mind, let me show you these things. Okay. So suppose for the, I'm now using Jupyter Notebook. So I'm actually writing import NumPy as NP. That means I'm importing the NumPy module. I'm also importing the pandas module. Let me run it here. It will take little time because two big modules. Okay, done. Since it has put a number here in this shell, that means it has actually done it, and it has not objected anything. Now I have a data file. Where I have kept the data file? In my machine, C: users, then my name, unfortunately is big, and then the desktop, and then there is a directory called demo, and then there is a COVID worldwide data. It's actually a Excel sheet. Let me show you the data in this form, in that form. Okay, here is the demo file. Here's the demo directory on my machine, on the desktop. Yeah. COVID means C. COVID. Here is the, you see, here is the Excel sheet. If you look at the data, if you open this Excel sheet, it will take little time because it's a big data, huge. There are lots of columns and rows, and my machine is also actually jammed. It is slow. Okay, it is opening. It's opening. Well. So you see this data file. Okay, you may not see everything: serial number, country, total case, total date, total recovered, etc., etc. All these things. It was the data, real data. I actually downloaded from the internet, from some authentic site. I think John Hopkins site or something. So they were maintaining this data, and I actually downloaded them and then tried to manipulate them with Python. And many people at that time actually manipulated with Python and did lots of papers, churned lots of papers out of it. Actually, I restricted myself. Okay, so this is the Excel sheet residing here in this directory. So I'm going to read this file. What I have to do, I am using this PD. PD means these pandas. Under that, there is a file called function called read_CSV. This is a very powerful function, and it reads any file, any data file from the any kind of data file. Particularly, most of the data file comes as, whether it is Excel sheet or anything. You can actually convert this as CSV. Actually convert this as CSV file, comma separated value file. Okay. Okay. And I have to give the path name, whole path name, and the file name, and with inverted comma, because this you have to put it as a string, and there is some technical reason I have to put it R. It's called raw string. You will eventually know what is raw string called, and so on. Okay. I hope you can still listen me. I hope you are still here. Okay, good. Because I'm always in fear whether it gets disconnected or not. Okay, so it is the data. Let's run it. So data is red. So what is the data? I mean, how does it look? I actually saved this as, assigned this name as a data, D-A-T-A. Okay, let's run it. And you see the file here. You see this, the presentation of data here. You can see, I think you can see serial number, country, total cases, total dates, total recovered, total active cases, total test, and population. And these are the automatic serial numbers, 0, 1, 2, 3, 4, etc., etc., etc. And at the end, it is showing 231 rows and 8 columns. Not very big data, but actual big data is very, very thousands of columns and thousands of rows and so on. But it's I mean, small big data. Okay, so and the data is presented that way. I mean, if you read the file, this data looks this. So what is this type of data? We asked. Let's see. Right? Let's type data. So it is showing it's pandas, then core, then frame. There's data frame. Basically, it's a data frame. I just showed you what is data frame. Okay, data frame means something. It's like a table. You see, these are the column indices, and these are the row indices. Okay, now, let's see what is the shape of the data. Like NumPy array, it has a function called shape. I can write this way as an attribute. This will also, you will eventually know how one thing write this way, how one thing write that way, and so on. It's a matter of some few hours and few days to learn, nothing else. Okay, so data.shape. The name suggests that you can actually see the shape of the data, which is actually given here. I mean, 231 rows and 8 columns, and it is actually written as a tuple 231, 8. That means 231 on one axis and 8 in another axis. Okay, since the data is very big, I may not be able to see all the data all the time. It's often not possible to a big, huge Excel sheet. Once I even read, the data frame cannot be seen entirely. So you can use this function called head. So data.head this. So I can actually see first 5 rows. If I write 5 data.head, say 2, then it will show actually 2 rows. If I actually write say 10, it actually will show first 10 rows. Okay, so this is about what is head. I can actually see the tail also. What is the tail? Is the tail. I mean, the last 5 data. I can actually write the tail, check the last 2 data, how they look. And remember, there are some names NaN. That means when you type in an Excel sheet, when you get Excel sheet from somewhere, in some places, when people are typing data, they may not. I mean, they may miss some point. They may miss some data. That means they keep it blank, or they write some comment or something else. If the computer does not understand, if the Python does not understand it, then it will write NaN. That means data is some data is there which is not kind of in a number, in the form of number. So it's called NaN, not a number. Okay. So that way you can understand where are the NaNs, and you can remove globally the nans, and then you can do manipulation. Okay, all kinds of things you can do. Okay, so you have the data, and you can actually see, you can actually convert data to _NumPy. That means the data frame, you can convert it to NumPy array. Let's see what it is. you have converted it to the, what is this capital X? Say capital X. Let's see the capital X. But see, this is an array. See, all the data that were the structured, now for my manipulation purpose, I have converted them to NumPy array, and this is just an array. You see square brackets. That means the data is one. That means one was a index number, then the serial number, then the country name USA, quote unquote, because anything that is doesn't I mean, it is not a pure number. Sometimes it is converted as a string. So it's a string. There's something. It's a kind of what something was written here. Total cases. It was written that way in comma separated way, a comma way, because Americans write this way, comma comma comma. That means ekok dash shoto hajar lakh nijut koti. 104 lakhs, etc., etc. Thousand. Okay, 140, 4,190. No, one million lakhs, thousand, and this way. Is it right? Okay. Well, these data is in the NumPy array, and since we have actually practiced NumPy array, so we know how do we handle a NumPy array. We can do that later. Okay, we can actually manipulate it. We can actually slice as part of it. We can actually add something over it. We can actually take the one particular column. We can actually slice a particular few rows out of it. We can do lots of things. These are called indexing and slicing. We can do indexing, slicing of a NumPy array. We can do indexing, slicing of a data frame, that this data frame also in the same way. Okay, let me show you here. Data means the data is basically this data. I'm actually using this data frame. Okay, this data frame. I'm using this data frame. Well, this data frame. Okay, now check data, and within it there is a function called LOC, location. LOC for location, and I can write data, then country, and this square bracket equal to India. That means I want to see where in this list where the India configures. I can see this India is here. India's data is here. That means serial number 2 and the index number 1. Index number 1 and serial number was given by them, and index number we are giving. I mean, the Python is giving automatically. Okay, so now we can, if we do that, it will show this India's data. It will just fetch the India's particular row. You see the serial number 2 and the index number 1 and country, total cases at the time, total dates, total recovered, and so on. You want to write X1, and so I can actually also this X, that's the NumPy array. 1 means this particular, this is 0. This is actually 0 element. This is 1 element. This is 2 element, and so on. If I have not talked about this, any say array, for example, any array or any say, suppose NumPy array, say 2790 minus 1, etc., etc. For example, if I see this is a NumPy array, if I see what is the X of 0, of course this is the first element. If I what is X of 1 element, this is actually 7. Okay, I can slice. I can tell, okay, pick these 2 numbers. That means X1 colon 3. Oh. These things are called slicing. If you don't know, you'll see that this is slicing. I can actually cut this out of it, and I can have this. Okay, so this is called slicing. This one is called, say for example, this one is called indexing. That means index number 1. It is fetching the index number 1. This is 0th. This is 1th. This is 2th, and so on. Okay. Please stop me whenever you are bored or you have a question. Okay. Now, this is a pure data that comes in Excel sheet. We can actually go to now internet and we can actually download raw data. Then we can read the data with CSV reader file, the function like this we have done, read CSV function under pandas. Then the data is data frame. If we read little bit about how data frame works, then we can see it, the manual of data frame, and we can manipulate a data frame. We can extract particular column. We can then plot those columns. We can convert them to NumPy array, or even to list or anything. So it's we can handle data very easily. We can actually handle data very easily. Okay. Any question, please? Any question? No question. Okay, please respond if you are not comfortable with, or if you have any question. Okay, so I'm giving you another example. For example, okay, another example is it's a 3D data. I told you that data is in 1D, data is in 2D, data is in 3D, and data in very many different forms. Okay, here, let's see here. Okay, I want to display the data, so that's why I want to import matplotlib.pyplot as plt. Okay, as I told you, and also this time I'm not plotting the data. I'm actually want to see a real image. Okay, any kind of photograph or any image that you take with your mobile or your phone or anything, or your DSLR camera or anything, that image, whether it is a JPEG file or PNG file or whatever, that image when read through the function in Python, it is actually, or any function in any programming language, it is actually a array of numbers. And this time, if you have a colored picture, it is basically a 3D data set. 3D means, I'll show you how it is. Let's see. And from matplotlib, there is a module called image. Image actually manipulates the images. It can read image. That means it can do image processing. That means what we actually do in mobile day out, day in, day out, is basically we click a picture, then we, with some editor, we can actually manipulate the image. We can actually give extra color. We can make it HDR. We can actually crop it, or you can rotate it, or whatever we do. Basically, all these are in the background. These are all mathematical operations. And basically, we are actually behind those, we are actually handling the numbers of those, manipulating the numbers of those images. I'll give you one such example. Okay, and my one image is wall under minus hyphen painting one.jpg. This is a picture that I took with my camera, DSLR camera, and I kept it in this demo. This the same here in this here, somewhere here, wall here, this something, say this wall painting. Actually, what I'm doing is that I'm trying to read these with some editor, and and this is the picture. Okay. So now what I'm going to do is basically I am giving the full path name of the image, and this time I'm reading through a function called imread, IMREAD, imread. Imread is a function which actually reads image, and where it is it is inside mpimg. What is mpimg? Matplotlib image. That means basically it's an image module in matplotlib. Okay, matplotlib is a package. Under that there is a image module. Under that there is a pyplot module. We renamed it here as PLT. We renamed it as a mpimg. It's my wish. You can give any name. Okay, let's now run this. Okay, oh, sorry. Let's first run this. Let's first run this. Otherwise, it won't be able to know. Okay, yeah. And what is this type of image? Basically, it's a numpy. You see, you had an image. You had an image just you saw, and the image is basically a numpy array. What is the shape of the image? So you now know image comes as a numpy array. It's a tuple of 3 numbers. That means basically 3580 by 5680 pixel, and there are 3 channels. That means red, green, blue. All the colors can be created. Any kind of a color on the art can be created by 3 basic colors: red, green, blue. So basically, you have actually 3 channels. So and basically, it's a 3-dimensional data, unlike the 2-dimensional matrix or kind of data file that you have. So basically, you remember data file is 2D, your picture file is 3D. So it's a 3D image. I mean, it's a 3D, not image, 3D data. It's a 3D data. But let's see the image now, IMG. What is this IMG? IMG is actually the image I read through this IM read. That means it is basically numpy array. And see, the image is now this numpy array. You see the numbers? The numbers are here, is a peculiar, the numbers are here all integers. And basically, all the numbers are converted between 0 to 256. I mean, 256 integers. I mean, 2 to the power 8 bit. I mean, 2 to the power 8, but I mean, this 8-bit numbers. Okay, 8-bit integer. So the numbers are here basically from 0 to not 256, 255. Okay, I mean 256 different numbers. Okay, and see the D type is UNIT integer. This is U is a special thing. You may not have to know at this moment. You can actually see what is the minimum of those numbers and the maximum of those numbers. The minimum of those numbers is 0, and the maximum of those numbers are 255. You can actually, I mean, see everything. You can actually, see all, I mean, various properties of a data file, of a array through very many different kinds of functions. Min is minimum, max is maximum. Okay, this min function is basically up here. It's inside the image, but the min and max functions are already in Python, basic Python also. Anyway, now we want to again we want to plot this. I mean, inside this PLT there is a function called imshow. That means actually I want to show this data as image show as image. Okay, let's run it, and it will now actually show the okay, now it actually show the image here. Okay, so here is the image. Okay, so it is read by, it is actually here created by this PLT dot imshow. Basically, what is this IMG? IMG is basically this 2D data. That means you can think that if you have a 2D data or 3D data, basically it's a 3D data, 3 square brackets, even 2D data, and you want to show, you want to see as an image, you can easily do that. Suppose you are doing some research work, you have some random data or some data from somewhere, you want to give a pictorial presentation of that for some purpose. You can actually create an image, not plot. I'm not talking about XY plot. You can actually create an image out of it. Okay, and then you have an image, you can actually manipulate the image. You can actually do lots of things. Okay, how much time I have? Please tell me. How much time I have? Do I have 20 more minutes or 30 more minutes?
Yes, sir, please.
Okay. Okay, so here. Okay, let's see. Something else. That means you have the IMG data, and then you write np.random.randint. What is that? I have not talked everything. Actually, you can always do that. I can demo here. You can actually, if you have NumPy, then inside that there is a function called random. not function, actually inside this NumPy package, there is a module called random, and inside there is a function called randint. And if you write randint, and if you write randint, and randint is say, for example, and give some, say, if you write, say, 1 to 10, that means it will create a random integer between 1 to 10. If you see, right, it creates 6. Again you run, it creates another random number. Again you run, it creates another random number. Again you run, it creates another random number. Again you run, and it's another random number, and so on. Suppose if you write something, some 3, 4, that means it will create random numbers and create a matrix whose elements are between 1 and 10. It is a 3 by 4 matrix, right? This is the size. You can write it as size equal to this. So this is this. Okay. Suppose I have the image, and I have created np.random.randint, and inside that I am writing some -100 to 200. That means I'm actually creating any number between 100 and 200. And I'm writing this plus this, means this number will be a constant number, maybe added with all the numbers of the IMG, for example. That means I'm trying to randomly distort the image. I call it image distort, for example. And if I want to see that distorted image, let's see how it shows. Yeah, it's already distorted because I have disturbed the numbers. So I have actually distorted the image. Okay, by adding additional numbers to each of the numbers. I mean, that way I can do lots of things. I can use a filter. Just a moment. Many of you who handle picture file, image file, you use lots of filters. In electronics, people do that. In real life, we do that. But what is a filter in terms of mathematics or something, or a computer algorithm? A filter is basically what it does. It actually does something on each of the pixels. That means it actually changes each pixel number. That means those pixel numbers are here. These are all the pixel numbers, image numbers, right? Okay. So what we do is I'm writing this matrix. Once you know a little bit of matrix algebra and so on, you know how a two-dimensional array can be multiplied with another two-dimensional array. That means one matrix with another matrix product, basically. People who come from mathematics background it is their job. They do it all the time, but people coming from other social sciences and other things, it may not be that regular for them, but it's easy to understand. I'm giving it's basically a three-dimensional matrix, and see, each number is 1/3. 1/3 means if you consider the dark is 0 and the bright is 1, 1/3 is the fraction, is basically the average. That means darkness and brightness you are actually manipulating, and actually you are you will be taking this is you can think this is a filter. So it's called we call it a gray filter. Well, and now I'm taking this image data, this basically a 3D data, and then we multiply. You remember at least one thing you remember, that means these are the pixels. That means x by x and y, and this other z coordinate, for example, 3. The last is 3. That means if we multiply this with a 2D or 3D array, where it has to start with 3. Here it is the ends 3, and so you see the filter size is basically 3 by 3. So it works. So it again becomes that by 3. Okay, because it is a 3 by 3. And if we now multiply, here, and this is a 3 by 3. If we now multiply, if use np.dot, that means dot product, that means it's a matrix product. I take the image data and take the this filter, I call it G, for example, and take the matrix dot product. Okay, and I then write this as image underscore gray. And now I want to see this plt.imshow, and this is something technical, image dot underscore gray, and then as type as integer, because I have to convert this as integer again, because the function can read only the integers. Because if we multiply by 1/3, it will be fraction, so it will be converting as integer. Anyway, so if you do that, you'll see. Oh, I'm sorry. It has to run, and it has to run. You see a gray image probably. You'll see a gray image. While it is working, this manipulation is showing. Because my computer is a little bit slow. See, the image is altogether gray. What we actually do in our mobile phone or on a computer or wherever, we can actually click a colored image and then convert it to black and white or gray image. But the background of it, behind the scene, actually we are actually manipulating the numbers. That means you have got some image, some data from somewhere, some remote sensing or somewhere, and the image you can actually, for some purpose, you want to convert this as a gray image for your analysis. You can actually do this way easily. You can manipulate them so easily. You can change the numbers a little bit, fractions, and you can actually the gray will be of different kinds. That means the entire control is at your hand. So that means basically you are doing basically the image processing stuff that people do, that all the image processing people that do basically. Okay, so if you know Python, the task is easy, and you can actually go deep inside what is happening. Otherwise, you can always use the software and you can do that. But still, it is good to know the knowledge when you actually handle data of different kinds, data of Excel sheet, data of image file, data of a sound file, data of different kinds. And you get to know what are those type of data and what you do with the data. I mean, what kind of, all the functions, all the modules, all are here. You can actually use them. Okay, little bit more. I mean, if you are not tired, I have created another matrix. Okay, here the these numbers. If you ask why those numbers, I'll tell you that okay, it's my choice. Basically, in standard the industry, people have manipulated, people have actually standardized different numbers for a sepia tone, to create a sepia tone, sepia filter, you see. And these numbers will create one kind of sepia tone. I can actually change the fractions and I can get a different kind of sepia tone. I mean, it's an oldish look. Okay. So see, here is a sepia filter. That means the filter means basically a matrix, nothing else. It's a 3 by 3 matrix. That's it. And we take the dot product of the image, original image data, and that means 3D numpy array with this S for sepia, and take the np dot okay, and create this sepia image, and then I actually show this. Let's run this. Okay, let's run this. It's doing, because it's a huge matrix. You can see that the matrix is, I mean, 5,000 something by 3,000 something and so on by 3. Yeah. So it is this sepia image. So that means you are doing image processing. You are changing the types and colors and of the images and so on. You can actually transpose the image. You can transpose on different planes. You can transpose. Okay. So you actually transpose the image. Let's see how you transpose the image. Yeah, you actually, basically you have rotated the image. X to Y, Y to X. That means these are the axis references. You will later know. Okay, swapping the axis. Axes are referred as 0, 1, 2, and so on. Like we call X-axis, Y-axis, Z-axis. In computer, they are called 0-axis, 1-axis, 2-axis. Okay, like we referenced axis inside the NumPy functions and so on. You can actually do lots of slicing and then transpose, then transpose and etc. etc. These are actually the taking one channel, and so that means the green channel is there, red, green, blue, and so the color is green, and so on. There's all kinds of things are there you can do. These are all details you can do. You can rotate a figure by any function. You can do and stuff, all kinds of stuff. You can copy image. You can actually invert the image. All these things you are actually basically doing. What I'm going to tell is that all these things you are doing by mathematical operations and computer programming. That's it. Okay. You can actually do this. You can. Oh, sorry. I actually do this. Yeah. Okay. And yeah, you can actually crop the image also. I told you that you can actually slice a numpy array. This is basically row slicing, and you are taking 500 to 2000 rows and 200 to 1400 columns, etc. Okay, and these another channel is kept as it is. Okay, this because image file is actually 3-dimensional. So actually you are taking some part of row, taking some part of column, and the red, green, blue, all the things you keep. That means the colon signifies you take all. So now you actually show. So that means it's a cropped part of the image. So that's how you are cropping. Cropping means you are actually, when you deal with the data, actually any kind of data, 1D data, array of numbers, single array, 2D array, 3D array. That means you can take a part of it, and that's called slicing. So you are actually slicing the part of the image data, and then you try to see it. It's basically a cropped image. That's what we do here, usually. We crop an image, right? You can actually add a subplot. That means you take one image and plot together, and two different image plot in the four different rectangles and so on. All kinds of things. These are all useful stuff that is given in Matplotlib chapter. You can actually follow that chapter or follow the manual in Python to do that. To create your own. Here, what we have done is a subplot. Actually, you have used the single image in 2 times, and the first plot, second plot. You always do that in your research paper or in your work or your project presentation, that you are actually creating different plots and images, and then they present in a different 4x4 form, 2x3, 3x2 form, 2x2 form, etc., etc. Okay. These are I'll skip. These are we'll skip. Then there is a bona fide, there is a very powerful imaging library is there, just to mention it now at the moment in Python. That's called PIL, Python Imaging Library. It's very powerful. We were actually doing the image manipulation with Matplotlib, because Matplotlib is basically plotting software, plotting app, with which you can plot 2D, 3D, contour image, statistical plots, pie plot, bar plot, 3D bar, etc. All kinds of things you can do. But also you can manipulate images. Also, of course, you can create animation. But also in Python, there is another module called PIL, Python Imaging Library. This is also very powerful. And I can just from PIL, you import capital IMAGE. This is another module in this package. And then inside this image module, there is a function called open, and simply open the file and then just run it, and it will give you you don't have to use another function in this case, and it will just open the image file, and actually show the file directly, because it's not a plotting software, it's actually image processing software. Okay, so once you are into image processing or data to image, image to data kind of thing, you can remember this name of this PIL, and can use. It's a for first time it's a little bit slow, and it's actually plotting in a huge way. So, and it's a big way. So that means that it has a better clarity and so on. So you see this thing. Okay, you can actually rotate. There is a image PIL, this image. You can actually rotate by 45 degree. You can do that actually, and actually it's taking time because I have not given any other parameters to control it. It's because it is actually it's actually plotting in a big scale, so that's why it is taking time. But it's actually 45-degree rotation of the image. These kinds of things you can do. You see the type of this. This is a typical, I mean, this special kind of file name, but you don't have to do anything like that. I mean, you don't have to remember anything. Let me give you, since I have a few more minutes left, I can just tell you a very basic introduction of a for 2-3 minutes, how actually you can create image from a just some data. Okay, I mean how the image is formed basically. See, I have written width equal to 100, height equal to 100, and here is a nice function called np.zeros. Zeros means you will create zeros of this height and this width and 3. Okay, let's see that. And you see the data. So data is all zeros by 100 by 100 by 3. Basically 100 by 100 by 3. Basically it's a 3D data, but it is all zeros. Why I'm creating zeros? Let's see. And it's all integers, right? Okay. All positive integers. And I can form an array, and I can see the image. Let's see. See, I can actually inside this image, and from array, that means this array of data actually created an image. So this is basically 100 by 100, total 100 by 100. I mean, these are all 100 pixels, right? Here are actually 100 pixels. We can see it. So 100 pixels this side, 100 pixels this side, and 3 channels here, 3 channels, and this is a black. You see, this is a black because all are 0. And now I create an RGB image, red, green, blue. Okay, let's see. np.zeros. Then some part of it is 255, and some part of it red, green, blue. I put red on, and I put blue on. That means I'm taking red and blue. See, this is a red channel, this is a green channel, this is a blue channel. Red, green, blue. In the 2 things, array, colon, this thing, 100. And that means I'm actually slicing data and putting it to 55 there. That's it. And I'm trying to see the image. Forget it. I mean, if you don't follow it, then I'm going to show you some of the demo. That means you actually actually you have a red box and you have a blue box. Okay, and see the shape 100 by 200 by 3. This is 200. This length is 200. Sorry, this length is 200 and this height is 100. That means 100 by 200 by 3. If you want to create some image which has another thing is called, you see, variation of intensity. It's called alpha factor. You'll see many images where the intensity variation you can do later on. I mean, by your hand, and I have done that. Okay, so you can see random number testing. You can see a random number and with color, but you can see black and white. These are numbers, random numbers. You can see a colored random numbers and so on. These are the not random. These are the I mean the systematic numbers. Okay, I think I'm talking at a stretch, so that it's definitely you will get bored. I'll stop now. I just want to tell you that we can, the same way, we can actually manipulate the audio files too. We can actually, I'm not going to demonstrate that today, okay, because it will be too much. I can actually create a Share Kama Pa Dhani. I can actually combine those Saregama Padhani means different notes, means different frequencies, specified frequencies, and I can actually create a chord. That means what you do in guitar and the piano and things like that, and actually combine them, and I can write a Python code and I can actually create music. Okay, or I can download a music. I can download a music, and I can actually see the actually I can see the background data file. That means at the end, what I'll tell you is that whatever you do in your life, you actually handle data, raw data in different Excel sheet form or any other form or any plain text file or any table or whatever. You actually handle image file, you handle sound file, whatever you do, where from it comes doesn't matter. It may come from space. You may create it. You can download it or whatever it is. Okay, everything that is read by Python, that is read by a computer programming. I mean the app. That means a module or a function in a module. It is basically a array. Either it is 2D array or it is 3D array, or sometimes it is 1D array. Basically 1D, 2D, 3D. And you hardly use 4D array, 5D array, 6D array, and so on, although the provisions are there. And once you have array in Python, once you learn Python, once you have arrays, that means you become immensely powerful. You become immensely powerful. You can manipulate those data. You can take a slice out of it. You can run a function over it. You can do mathematical operations on one particular axis. You can do statistical analysis and so on, etc. Okay, with this note, I will end, but just one mention that I have not shown, I have only shown you the tip of the iceberg, because there are once people you are in kind of people who work with data, lots of data. You have to use this. You need to know, you use statistical analysis. There are lots of statistical modules and functions in Python itself. I will show you them another day, or you can go to Google and search. That's what I can tell you. I think I will end my talk today. You can ask question.